Hello everyone, myself Aftab Alam and I have graduated from Coaching University Kerala and I am teaching mathematics for the last 5 years in motion education. So here I am going to discuss indefinite integration today, and before starting this indefinite integration I will explain what is the actual meaning, what is the basic meaning of integration, why we say integration, okay, and after that I will explain why we called it indefinite integration. So I am going to explain here first means what is called integration. So integration is the reverse process of differentiation. Integration is the reverse process of differentiation. Reverse process of differentiation. Reverse process of differentiation. This is the basic definition of integration. Integration is the reverse process of differentiation. I will explain later why we called it like this. Second point number 2. It is also called antiderivative. Antiderivatives, or you can say primitives, or you can say integral also. Integral. So this is the other names of integration. You can remember this, means antiderivative you can say, or you can say primitive also, or you can say integral. Suppose means primitive of, if suppose they are asking primitive of sin x, so we can say that means sin x integration. So we can say in like this, sin of integration of sin x is minus cos x plus c. Okay, so you need to remember this, means if they are asking about primitive of sin x, so you need to understand this, they are asking about means integral of the sin x. So integration you can say, or you can say antiderivative, or you can say primitive also. Okay, so I am going to explain next point. See this here, what is the next point? Suppose if a small f of x plus c, a function is there. Suppose I am going to consider a function a small f of x plus c, and the derivative of this function, if the derivative of this function, then I am getting here capital F of x plus capital F of x. Okay, if we are going to differentiate this function, then we are getting capital F of x, and we know that this dx is movable, so we can write capital F of x dx, and in a way we are getting here derivative of f of x plus c. Okay, now I am going to integrate both sides. So what we will get, see this here, I am getting here integration capital of capital F of x dx, integration of capital F of x dx, we are getting here a small f of x plus c. So see this here, we can say from here integration is the reverse process of differentiation. I am going to differentiate this function, when I am differentiating this function, then I am getting capital F of x. But when I am going to integrate this function, then I am getting this small f of x plus c. So we can say that this is the reverse process of differentiation. Reverse process of differentiation. Okay, so I am going to explain with example also. See this here, this is the actual concept. I am going to explain with, suppose see this here, derivative of d by dx of sin x. What is the derivative of sin x? We know that cos x. Okay, if we integrate this function, then we will get this. We are differentiating sin x, then we are getting cos x. But I am going to integrate this function. See this here, cos x dx. So what is the integration of cos x dx? You can say, sir, sin x plus c. So we can say that this is the reverse process of differentiation. Means when we are differentiating the sin x, then we are getting here cos x, and when we are integrating cos x, then we are getting sin x. So we can say from here integration is the reverse process of differentiation. I hope you are getting these all the things whatever I am going to explain here. So this here, next point, some important highlight I am going to explain here. Important highlights regarding indefinite integration. Okay, Now you can easily understand why we called it indefinite integration. Okay, so first point I am going to explain here. See this here, integration of capital F of x dx. When we are integrating this function, then we are getting a small f of x plus c, and this geometrically represents a family of curves whose tangent at the same x, whose tangent at the same x are parallel and having slope capital F of x. See this here. This is means integration of capital F of x dx. We are getting a small f of x plus c geometrically represents a family of curves. How? I will explain here. And whose tangent at the same x are parallel, okay, and having slope f of x. See this here. How? See this here. I am going to explain with example here. See this here. For example, I am taking here. What is the integration of 2x? What is the integration of 2x? So you can say easily, sir, integration of 2x is x square plus c. Is it okay? Yes. Integration of 2x dx is x square plus c. So I am asking a question. Tell me, what is the derivative of x square? So you can say x square plus 0. I am asking. Same thing. Both are same. What is the derivative of x square? You can say 2x. What is the derivative of x square plus 1? So you can say easily, sir, 2x. Derivative of x square plus 2. You will say again, sir, derivative of this one is also 2x. I am asking derivative of x square minus 1. So again you will say 2x. What is the derivative of x square minus 2? So you can say easily 2x. Okay. So see this here. You can observe from here one thing. This c is taking different values. This c is taking different values. See this here how. This c is taking different instead of this c, when I am putting 0 and after and I am differentiating this function, then we are getting 2x. Instead of this c, I am putting 1, 2, minus 1, minus 2, and we are differentiating this function, and we are getting here 2x. So you can see this, you can say from here, means this c is changing different value, means the c is taking 0, 1, 2, minus 1, minus 2. In a similar way, if I will ask you dy dx of x square minus 1000, tell what is the derivative of this? Again you will say 2x. So this is the this means x square, derivative of the x square is equal to 2x, and derivative of this one is also 2x. So we can say that this geometrically represents a family of curves whose tangent at the same x are parallel. How? See this here. I am going to explain with graph. What is the graph of x square? So you know that upward parabola in this way. This is the graph of x square. What is the graph of x square plus 1? You need to shift 1 unit upward. So this is x square plus 1. What is the graph of x square plus 2? Again x square plus 2. X square minus 1. You need to shift 1 unit down. So this is the graph of x square minus 1. In a similar way, you can say this one x square minus 2. Now what I am going to ask, see this here. I am asking what is the derivative of x square plus 2, x square plus 1, x square minus 1, x square minus 2. This is actually x square minus 2. This is actually x square minus 2. Okay, now I am asking, tell me what is the derivative of this function? Okay, see this here. I am going to consider a point x equals to a, and after that what is the derivative? What is the derivative of this? And whose tangent at the same x are parallel. See this how. What is the derivative of this one? 2x means derivative of x square plus c. Derivative of x square plus c, always we are getting 2x. If I am asking at x equals to a, then what we will get? We will get 2a. So what we will get here? Tangent at this point 2a. Here 2a, 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 2a at x equals to a. Derivative of this function 2x at x equals to a, 2a. In a similar way, x square minus 1, what is the derivative of this function? 2x at x equals to a. So we are getting 2a, 2a, 2a. So we can say this one is the parallel whose tangent at the same x, tangent at the same x are parallel, okay, and having slope f of x, okay. Slope of this function will be always same. Slope of this one is what we are getting? 2a. So we can say that this one is geometrically represents a family of curve whose tangent at the same x are parallel and having slope f of x. Next point I am going to explain. Point number 2 means I am going to write here, suppose integration of capital F of x dx is equal to, we are getting here f of x plus c, small f of x plus c, okay, and we know that this one is integrand, this is integrand and this is integral, okay, this is integral. We know that this is the integrand. If integrand is discontinuous, if integrand is discontinuous, that does not mean integral will be, integral does not mean integral will be discontinuous. Integral will be discontinuous. See this is how. If integrand is discontinuous, that does not mean integral will be discontinuous. How? If this integrand is discontinuous at some point, it does not mean integral will be also discontinuous. How? See this here. For example, I am going to explain here with example. See this here. I am writing here 1 upon x raised to the power 1 by 3 integration of this. So what we will get? We will get here 3 by 2 x raised to the power 2 by 3 minus 1 by 3 plus 1 x raised to the, you can write minus 1 by 3 plus 1. So what we will get? 2 by 3 x raised to the power 2 by 3. So we are getting here in this way. So see this here, this function is discontinuous, means integrand is discontinuous at x equals to 0. This function is not defined at x equals to 0. But integral, this one is the integral, or you can say answer. So this integral is continuous. So from here we can conclude this point, means if integrand is discontinuous at some point, it does not mean integral will be also discontinuous. Integral can be continuous also, okay. So this is the second point. If integrand is discontinuous, that does not mean integral will be also discontinuous, okay. So I am going to explain point number 3. Integration of a periodic function, integration of a periodic function, need not to be a periodic, need not to be a periodic, need not to be a periodic. Integration of a periodic function need not to be a periodic. How? See this here. I am going to explain with example again. I am writing here like I am taking cos x plus 1, cos x plus 1 integration of this. What we will get? What is the integration of cos x? We will get here sin x, and one integration, it means x plus c. So see this here, one thing I am going to explain here, means this function is periodic or not. Yes, cos x period is 2 pi and this is periodic with period 2 pi plus 1, answer will be same. So we can say this is periodic with period 2 pi. So this function is periodic with period 2 pi. Now see this here, this is also periodic. Yes, periodic period of this function is 2 pi, and this is x is linear. So we know that what is called periodic. Periodic means a fixed means in a certain interval graph, if graph is repeating, that is called periodic. See this here, y is equal to x, this graph is not repeating at fixed interval, so we can't say, we can say this is not a periodic. So this is non-periodic, this is non-periodic. So a periodic function plus a non-periodic function, we can say that this is non-periodic. This is non-periodic. Okay, so periodic function plus non-periodic, we can say that this one is non-periodic. Okay, so from here we can conclude integration of a periodic function. Integration of a periodic function need not to be a periodic. See, this function is periodic. Integral of a periodic function need not to be a periodic. This is a periodic, but this is not a periodic. So we can conclude easily periodic function means integration of a periodic function need not to be a periodic. So I hope you are getting these all the things whatever I have explained here. So first of all I am going to conclude these all the points. Integration is the reverse process of differentiation. Second point, integration is also called means antiderivative, primitive or integral. Okay, and suppose a small f of x plus c, if you are differentiating this function, then we are getting capital F of x plus c. And after integrating capital F of x, we will get here a small f of x plus c. So we can say this is called reverse process. Integration is called reverse process of differentiation. And after that, some important highlights was there. So integration of capital F of x dx, we are getting a small f of x plus c. This geometrically represents a family of curves whose tangent at the same x are parallel and having slope f of x. Okay. Second point was means integrand is discontinuous. If the integrand is discontinuous, that does not mean integral will be also discontinuous. And point number third was integration of a periodic function need not to be a periodic. So I hope these all the things are very easy.